everyone, and welcome back. Today we have 20 valid parentheses. It says here that we're given a string S containing just the characters of these parentheses. So we're only getting these, from which we are to determine if the input string is valid. And an input string is valid if the open brackets are closed by the same type of brackets, and the open brackets are definitely closed and in the correct order, and every closed bracket has a corresponding open bracket of the same time. So that basically means whenever we have an open bracket, we're closing it and in the same order. So if we had this and this happened to be like that, let's say, then this should be closed in the same manner. So in the same order. Maybe let's try an example. So let's say we have some brackets. Okay, so this is our input string, and our input string, let's initialize it as some set of brackets. Let's say that, and we have something here, and something here, and something here. And this is valid because in the same order, every bracket is being closed by the same bracket. So if we do it in color, this would be a valid bracket. It opens and closes itself. If we remove that, then the next one would be these, and then the next one this, and then the next one like so. All right. And the way we can go about this is actually considering that there's two scenarios. The scenarios are, one, either it's an open bracket, because remember we're guaranteed to have only these characters, or two, it's a closing bracket. Now, if it is an open bracket, what we can do is initialize a stack, and in this stack we can keep track of all the elements which are opening by keeping track of the expected close for the opening. So if these are the opens, and let's say we have some mapping, right, where we say the open is closed by this, the open of this guy is closed by this, and the open of this guy is in turn closed by this, closed by this. Okay, and so and then that's the first condition. The second condition is if it's a closing bracket, then what do we expect? So if it's an open, we insert it here. However, if it's a closing bracket, so if it's not in one of the keys, because this is the key, this is the value in the mapping, if it's not one of the opening brackets, it must be a closing bracket. And if it is a closing bracket, then we should have in our stack in the order inserted. So from the last one would be the closest one that was inserted, which we are expecting in order to close our closest opening bracket. Okay, so let's try over here. Let's try iterating this. So we have an opening bracket, it opens. So because it opens, let's insert whatever is expected. So that's the close. So let's add that here. Okay, we're done with this guy. We have another opening. So let's insert its closing over here. Great. We have another opening. Wow, this is very nested. So we add the corresponding close. We have another opening. So we insert the corresponding close. And at this point, we see that, okay, these were all opening. Now we're finally at a closing because this is not one of the keys in our map. So because it's not one of the openings, it must be a closing. And then we check, okay, what's the last one here? What was the one that was most recently added? And that's this guy. And does this expected next closing bracket match our current character? It does. So that's great. We continue. But let's say it didn't match, then we would return false. Okay? So we're done with that. We're here, and we popped the last guy off. So again, it's a closing, and we see that the next one also is the correct expected closing value here. And then you can see that we'll go through these like so, and we'll be done. Now, what if we had, let's say, a opening bracket and like that? Then our stack, and let's make it more interesting. Let's say it's like this. Our stack, when we're at the first position, we would be inserting a closing bracket, and then here a closing bracket. But then once we pop this guy off, because this is open, this opens, this closes, we found the match, so we pop this guy off, we pop this guy off. This is still not valid because not all the parentheses were closed, and we can tell by looking at the stack, which is not empty. Now, those are two scenarios, but let's go over one more scenario where we do have this one. We do have a close. Okay. In this case, what's different? Let's do it like that. Now, in this case, what we see is if we iterate, because this opens, we add the corresponding close. The next one, this one, because it's also an open, this is an opening type, we add the corresponding close. And then we're here. Now this is a close type, and our next expected closing bracket to match with the closest, the nearest opening bracket, is actually this one. However, our current close bracket is not matching, and so we see that this is not valid, and we return false. Okay, so let's try this in code. Now, basically we had some mapping, and maybe I'll call that pairs. And inner pairs is a dictionary where we keep track of the open to the close. So the key is the open and the value is the close. And let's initialize that. Okay. Now, what we did was we had also a stack, which will keep track of all the expected closing pairs to our opening pairs. And for every char in string, what we can say is there's exactly two scenarios. Either it opens or it closes. So the easiest way to check if it opens is just checking if it's in pairs. If it's a key in pairs, then it's one of the opening brackets. So if C in pairs, then it's simple. We just add to stack whatever is the corresponding close value. So let's add that. Now, otherwise we check a few things. Otherwise, we check, first of all, if the stack is empty. Now, if we're in a character, which is a closing pair, but our stack is empty, then we don't match. Either the stack is empty or the latest pair, the latest closing icon, does not match our current icon. So otherwise, if either stack is completely empty or whatever is the last value in stack does not match our current char, then we return false. Otherwise, we continue on, and at the end, remember we had this one scenario where it was technically valid to the end of the loop. However, we had this one. We were technically valid until the end of the loop, but we had our stack, which is not empty at the end of our iteration, because this one was closed with this guy, but this one was never closed. And so we say if stack is empty, then we are valid. So if not stack, meaning if stack is empty, then it's valid. Otherwise invalid. And we can submit. And there you have it. This was once again 20 valid parentheses. Thanks so much. Happy coding. See you next time.